For over 4,000 years, the Great Pyramid of Giza has stood as the ultimate architectural enigma. Built for the pharaoh Khufu, this monument contains over 2 million individual blocks. How did a Bronze Age civilization, lacking iron tools or the wheel, transport and lift these megaliths hundreds of feet into the air?
Some have pointed to supernatural forces, but modern science reveals a story of human genius, sophisticated logistics.
The scale is staggering. Some granite beams roofing the king's chamber reach 80 tons, a weight that
Archaeologists now believe this was not the work of slaves, but a highly skilled, well-fed workforce of tens of thousands of Egyptian citizens.
excavated cemeteries show that these builders received medical care and a diet rich in beef, bread, and beer, fueled by a national tax system.
This was more than a tomb. It was a project that defined the Egyptian state, unifying the population.
But before a single stone could be laid, a foundation of absolute precision had to be leveled across 13 acres of bedrock. The orientation is nearly perfect, aligned to the true north with an accuracy that rivals.
The journey of the stones began in the quarries, where masons used arsenical copper tools and dolerite hammers to carve the earth.
Copper chisels were soft, requiring a constant cycle of resharpening by dedicated teams of smiths working in nearby camps.
For the hardest stones, like the red granite of Aswan, the Egyptians turned to a grueling process of sand abrasion and pounding.
These granite blocks, some weighing 80 tons, had to be transported over 500 miles from the southern quarries to Giza.
For decades, the transport of these stones across the desert was a mystery, but new evidence points to a lost world of water.
Satellite radar has detected the Ahramat Branch, a 64-kilometer-long extinct river.
This waterway allowed heavy barges to deliver stone directly to the construction site, bypassing the impossible task of dragging them over miles of sand.
In 2013, the discovery of the Diary of Merer provided the first written account of this transport system.
Merer, an ancient inspector, documented how his crew moved elite white limestone from the Tura quarries to Giza by boat. This logistical masterpiece meant that the Nile's annual flood was not an obstacle, but a vital tool for moving a mountain of stone. Once on the plateau, the stones faced their final and most difficult journey, the lift to the top of the pyramid. For centuries, the straight ramp theory was the most popular explanation for how the Egyptians reached the higher levels.
But to reach the top of a 480-foot structure, a straight ramp would need to be over a mile long, containing millions of tons of material.
Such a ramp would have left massive archaeological footprints in the Giza sand, traces that have never been found. This has led researchers to look for more efficient, less intrusive ways the Egyptians might have conquered gravity.
One alternative is the spiral ramp theory, where a road winds around the exterior of the structure like a giant corkscrew.
While this saves material, a spiral ramp would cover the pyramid's face, making it impossible for ancient surveyors to check the precision of the angles.
As you can see, the internal spiral corridor winds upwards. This specific structural joint suggests.
In this internal ramp theory, stones were dragged up a 7-degree incline, hidden within the core of the pyramid itself. At each corner, a temporary open notch would provide the space needed to turn the massive blocks 90 degrees for the next leg of the journey.
Further evidence came from thermal imaging, which revealed strange anomalies in the pyramid's temperature, suggesting hidden corridors within the stone.
But regardless of the ramp's shape, the problem of friction remained. Dragging a multi-ton block across dry sand is nearly impossible. A wall painting from the tomb of Jehuti-Hep reveals a surprisingly simple solution: a worker pouring water in front of the sledge.
For years, scholars thought this was a ritual, but modern physicists have proven it was an engineering masterstroke.
Wetting the sand creates capillary bridges between the grains, doubling the stiffness of the surface and reducing the pulling force by half.
With this technique, the Egyptians turned the treacherous desert into a smooth, solid highway for their multi-ton loads. But even on wet sand,
the heaviest granite beams of the king's chamber, weighing 80 tons.
New theories suggest that the Grand Gallery was not just a corridor, but part of a massive internal counterweight system. The walls of the Grand Gallery show strange rang and hoke that perfectly match the mechanics needed to guide these heavy weights.
For smaller stones, the Egyptians likely used levers, a technology described by the Greek historian Herodotus centuries later.
Experimental archaeology has shown that just 5 men using simple wooden levers can lift a 2-ton block several feet in minutes.
These levers were likely used for the top 3% of the pyramid's mass, where space on the ramps became too narrow for large teams. The final stone to be placed was the pyramidion, the capstone, often covered in gold to reflect the rays of the sun god, Ra. Once finished, the pyramid was encased in polished white Tura limestone, creating a brilliant, seamless surface that could be seen for miles. But for over 4,000 years, the internal secrets of how it was built remained hidden behind millions of tons of solid stone.
Today, a new generation of scientists is using Muon radiography, cosmic rays from space, to see through the pyramid.
Muons are elementary particles that pass through stone but are slightly absorbed.
In 2017, the Scan Pyramids project detected a big void, a hidden space at least 30 meters long.
Is this void a structural feature designed to relieve weight, or a secret corridor used in the pyramid's construction?
It is truly astonishing to stand here today and witness the enduring legacy of the pharaohs.
Advanced scanning and robotic tools have pinpointed a 30-meter corridor leading to a mysterious, sealed door deep within the structure.
This discovery promises to rewrite a chapter of ancient history, potentially revealing the final resting place of the pharaoh's treasures.
From the lost Ahramat River to the physics of wet sand, we are placing ancient myth.
The Great Pyramid stands not as a riddle of the gods, but as a testament to the limitlessness of the human mind and collective will. The sheer scale of moving 2.3 million blocks in just 20 years requires a block to be set every 2 to 3 minutes.
This required a level of bureaucratic and logistical management that rivaled the most complex modern aerospace programs.
The lost river Ahramat was the key, a 64-kilometer waterway that brought the stone mountains directly to the pharaoh's door. This river likely dried up due to drought and desertification, burying the secret of the pyramid's construction under miles of sand. Only now, through radar and core sampling, can we see the water highway that made the impossible possible. Every block was a challenge of physics, but the Egyptians mastered the mechanical advantages of slopes, sledges, and lubrication. By reducing friction by 50%, they could move blocks with half the workforce, a secret hidden in plain sight on tomb walls.
The massive 80-ton granite beams in the king's chamber remain the greatest testament to their mastery of heavy lifting. These beams were lifted over 200 feet above the plateau, a feat that suggests the use of advanced counterweights.
The Grand Gallery, with its corbelled ceiling and sloped benches, was the perfect machine for such a gargantuan task. Recent scans show that the big void mimics the shape of the Grand Gallery, perhaps a second counterweight system for the final levels.
This would mean the Egyptians built a machine of stone, a resurrection engine that doubled as a construction tool. As the pyramid rose, the ramps were recycled, their stones used to fill the upper layers of the monument.
This internal ramp approach would leave the exterior faces clear for the final polishing of the white limestone casing. The result was a shining star in the desert, a monument to the pharaoh's journey to the northern stars.
Every block was leveled within a fraction of an inch, using only water, copper, and wood.
This accuracy is comparable to modern laser leveling, achieving a standard that would be difficult to replicate today.
These were not nameless slaves, but proud craftsmen whose names were written on the stones they hauled.
They worked in files or teams, competing to see who could move their blocks the fastest. This national mobilization created the identity of Egypt itself, forging a people through a mountain of stone. But even as the structure was completed, the secrets of its inner chambers were sealed away for millennia.
Today, we stand on the threshold of a new revelation, guided by the silent rain of cosmic particles.
The 30-meter corridor recently detected points toward a final, unopened mystery that could change everything. In 2026, the world will watch as we finally see what lies behind the door Khufu closed 45 centuries ago. Modern archaeology is no longer about the shovel, but about the scanner, the robot, and the particle detector.
These non-invasive tools allow us to preserve the monument while uncovering its most intimate secrets.
The Great Pyramid remains the only surviving wonder of the ancient world, a testament to human ingenuity.
It was built by a people who understood the stars, the river, and the very limits of physical possibility. As we prepare for the 2026 revelation, we are reminded that the past is never truly silent.
What lies behind the door? A king's treasure, or the final proof of how he built his eternal home? Soon, the mystery that has baffled humanity for 4,500 years will finally be solved.
The Great Pyramid of Khufu, a monument of stone, a machine of genius, and an eternal challenge to our imagination.
Join us in 2026 as we open the final door and reveal the secrets of the Giza giants.